So, lunar application of the foam engineering could be to take and fill large polar craters that never see sunshine at the bottom and mount to the surface all the way around really tight and begin to seal it in as part of the structure and weigh down the structure with indoor farming and stuff. All this activity warms as you build the layers down below the solar panels that cover the dome. And a dome over a crater like this with solar panels would get sunlight on half of the dome all the time. You'd get that much. And that's pretty good. You can make it a cone to make it more efficient, and would be a good structure. But down into the thing, as you mine the solids out of the bottom, which accounts for ice. Ice would be solid at this point, at these temperatures. And you pull that material up, you process it, clean it of any contaminants, heavy metals or whatnot that you might find in batches of the water, and use that in your indoor farming on the moon. A centrifuge, dolly style, built inside the rim, under the foam, to take advantage of less stringent structural requirements due to the shielding and air compression, life support and all that being separate from the centrifuge, which is contained within the volume of enclosed space. So in the volume of this enclosed space, you grow indoor farming. You could use thorium, nuclear fuel, or other forms of small nuclear power plants, perhaps out away from the dome. You could use liquid propulsion to produce rotation, to motor action, and use the exhaust could go into mining areas that don't have good seal. You don't need good seal. You got robots in there. You don't care what gas you use that is heated and compressed, and let the ash fall out and you just gobble it up anyway. It's all dirty in there anyway. And your guys go down there in spacesuits anyway. So as long as the gas itself isn't corrosive, if the pressure differential in there is good, that means you can walk around in a fully fledged positive pressure spacesuit and do all kinds of stuff. And let the robots do most of the work. And they just eat into the surface. Whatever metals they get out, they process that into more structural materials. Now, bamboo would be a good option at this point if it were grown in such a way as to produce lots of stock material for structural woods, structural beams. Instead of using metal for the whole volume of the 3 meter struts, you could actually use thick-walled, engineered bamboo tubing, woven together from bamboo strips, all laminated together with a hollow core. Call it 1/3 of the diameter would be an opening all the way through. And you just glue on your rotation cups with the hinges on them on both ends in a jig, so they're all the same length. And those are rigid struts, and you could take half of it be bamboo and the other half be a metal cylinder with a O-ring, and the bamboo engineered tubing, which is not just bamboo cut and hollowed. It's bamboo that's stripped down for its fiber, and the fiber rewoven into an engineered structured item that's precision. Now this bamboo tube has a hollow core which can contain enough gas to act as a compression joint with a metal sleeve, say steel, stainless steel, with a gasket, an O-ring, and some oil. Slide across there. So when you can't turn Martian air or Mars exhaust gases into metal, you can use them for building bamboo structural members that actually act like a shock absorber, exactly like the main plan dictates. That's really cool. These are pieces where the train grinding along, that looks like corn. That's really cool. Look at that. That's really beautiful. It's really neat. That's sintered. The grinding metal attaches to a nearby metal object on a train and eventually becomes this big piece pointing towards the source of the grinding, and is either broken off by one of the guys as he's maintaining the vehicle, or they just bounce loose and they end up here on the side. And this one, I think we'll plant this tree right here. Just wiggle it in there really good. Hold it. Jack it up a little bit with some rocks. Yeah, just like that. There we go. Yeah. Just for fun. What do we got? Looks like 7 minutes. Okay, so how do we do some work here on Earth to mimic these ideas? One is go ahead and build the compression struts, right? And cover 30 acres with them, you know, as high as you can, reasonably, and start building structures inside to determine a standard for 1G. If it'll survive 1G, it'll survive 1/3 G or 1/6